You are looking at a man with a plan, except this plan hasn't been drawn to scale and has no dimension. So really you're just looking at a man with a bit of a sketch on a piece of paper. But we're going to be turning that pile of wood into a workbench. So let's get started. Hello and welcome to another episode of James Dean Designs. Now today I am building a workbench. This is primarily for my CNC machine, but in reality it can be used for lots of different things. Now a second ago I showed you my quick sketch that I did on the PC. So let's take a closer look at this and I'll explain some of the decisions I made before we get into the build. Now I'll start by saying that I will put a full cut list about this project in the description area so you have everything to work from. In terms of the design of it, we'll work into a standard sheet of plywood, so 4 foot be 8 foot or 1.2 metres be 2.4 metres. The framework is all built out of 4x2 and I'm going to double up on the legs to give them a bit of extra strength. Now in terms of the design itself, you will notice that there is an overhang on the front and the back. This is quite deliberate. One, I've brought the legs in to give the middle a little bit more support, but I also want to have sort of a bit of a desk area at the front where I can get a chair or a stool underneath when I'm working on my laptop, and towards the back I'm probably going to box this in with a dust collection system, so somewhere to hide the vacuum and minimize the noise. In terms of the base frame, obviously this is just going to give the legs a bit more support, but I'll also be putting a sheet of OSB on there to act as a little bit of storage. In terms of tools, I'm trying to keep this as simple as possible. I've got a couple of tape measures and pencils because they always go missing whenever I start working. You want some sort of set square or speed square to help you draw a few straight lines. Obviously we've got some drill bits. I do have some countersink ones. These make life easier but are not necessary. We have a drill and a driver, obviously just to speed things up a bit, and a whole bunch of screws. Now I do have a jigsaw as well as a chop saw. Now please bear in mind these are some of the cheapest available. They are nothing fancy, but everything that can be done with those can also be done with a normal saw as well, and obviously a spirit level just to finish off later on and make sure everything is as flat as possible. Now I will mention I am not a professional woodworker. This is just a hobby DIY project, so I've picked some things up along the way, but my knowledge is still fairly basic. But what I would say is if you are building a workbench like this, make sure you get good quality timber before you start. I don't mean expensive timber, I simply mean that your sheet material is flat and your lengths of wood are not twisted or bowed. Obviously the better condition it is in, the easier it will make your life when building the workbench. Now, to make life easier, I'm literally going to build the frame on the piece of plywood itself. This is obviously to aid in the measurements but also to make sure everything remains square. Now the thing that's annoying about the lumber industry is it makes the plywood at 244 centimeters long, but it makes the length of wood 240. So there is a 4 centimeter offset. Now the reason that this is annoying is normally when I'd be building a frame like this, I'd have the two long pieces on either side and then all of the connecting pieces would be exactly the same length. I'm going to have to change it up slightly, so the two end pieces will now go the full width. The long pieces here will sit inside of those, and then these shorter pieces will connect everything on. So let's get this all cut and I can show you what I mean. I'm going to start to assemble this, but one thing I have done is built me a very simple jig. Obviously we've got to pilot a lot of holes, not only for the outer frame but then doing the inner pieces as well. So this just guarantees that we're going to get all the pilot holes in exactly the same position. It's very simple. Put it in the end, hold it in place, obviously bring the drill in and then just spot those holes. And it just guarantees that your holes are then going to align all the way around, and obviously it looks much neater as well. So we get all 4 corners drilled and screwed up. The outer frame is now assembled. Obviously take care to keep things square as well as aligned to your base itself, obviously, so everything matches up. Now for the next stage we need 2 measurements. The first is the inner on the width, so we can cut our 5 battens to length. What I would say is take a couple of measurements along the way and then take the average just in case any of the wood bows or twists along the full length. The second measurement we need is actually to determine where those 5 battens go. So we're going to take the inner measurement on the opposite way and then we're going to divide that by 6. Because we need 5 markers for those battens, we divide the total length by 6 and that gives us the offset for each one. So we'll get that done now. So what we've now done is cut all the middle pieces to length, mark them accordingly down the edges and then put them in place. We've also done the pilot holes. I put a centre line down my little jig and it just allowed me to basically put it on that centre line, drill the holes and guarantee they all line up. So the next thing to do is to get all the screws in, obviously pinch this all together and just firm the frame up even more. So that is the main frame now cut and obviously all assembled. There are a few gaps starting to appear around the edges. I don't know if this is slight twists in the wood, the floor may not be perfectly even. The reality is there's not a huge amount I can do about it now, obviously, until we get everything flipped over and fully assembled. And then hopefully everything will pan out in the end. The next thing I need to do is start to build the legs. Now what I'm effectively going to be doing is pinning two pieces of 2x4 together, obviously to give us a nice thick chunky leg. Now in terms of the height of your table, obviously this is going to vary from person to person. I usually like mine somewhere between around 90 to 95 centimetres high, so effectively just under a metre. That seems ideal for me, but obviously if you're taller you may want it higher, if you're shorter you may want it a bit low. Do remember these are fairly big workbenches, so you may be leaning over to reach the centre areas. So do try and judge that, but ultimately obviously if you are nervous, maybe cut them a little bit long and obviously you can always cut them down later on. Now just as a quick tip, if you are unsure of how long to make your legs, one of the simplest ways is just cut one roughly to where you think it may need to be. Obviously if you are adding casters like I am, factor this in as well. Put it in place and then just stand next to it. Ideally you want it to be somewhere around wrist level when your arms are dead straight. This is ideal for me. This is cut to 90 centimetres or 3 foot. So yeah, this overall height bench works for me, but as I say, it's about finding what's right for you. And it's just a quick, simple way to possibly try and test it. So all the pieces have now been cut for the leg. And as we can see, it's effectively two halves. We've got a full length piece and then one that has been sectioned up to allow for the subframe to slot in. Now technically this does weaken the leg, obviously, because it means most of the weight is just going on that one leg. But as long as you make that a good fit, it should obviously add a bit of extra support. These have just simply been screwed together, as I say, to make it a larger piece of wood. Now the next step is to complete all four legs, do exactly the same as this one, and then fit them in place to the frame. So all of the legs have now been assembled, and the next step is to, well, fix them in place and make sure they are secure. You will need to screw them in from different directions, so make sure you offset the height or positions of the screws because you don't want them clashing. You also need to give a bit of further thought to how you're going to flip this over, and this is quite key in terms of not damaging your workbench. You have a couple of choices. Obviously, if you have a second pair of hands, someone to help you flip this over, great, continue what you are doing and fix everything in place. If you are doing this on your own, what I would probably suggest doing at this point is lift this frame up slightly above the height it needs to be on some scrap pieces of wood, some workhorses, that type of thing, and fix the legs in from underneath in the correct way so you don't have to flip the frame over later. I'm going to continue to build it as it is, but as I say, something to bear in mind for the next step. So we're now getting ready to measure up and cut the subframe for the lower shelving. But obviously what we ideally need to do is make sure that our legs are fairly square to the base frame. Now obviously if you have a large square, excellent, put that in place, check all is square. Not only this side, but all four sides in terms of the balance of the legs. If you don't have a large set square, one of the easiest things to do sometimes is measure diagonally from corner to corner, then the opposite two corners. Those measurements should match. If they are slightly out, obviously you may just want to try and flex those legs a little bit to get them as close as possible to being square. Yes, ideally they should be perfect. If they are a little bit out on a frame like this, it's not going to make too much difference because ultimately obviously wood does move anyway. But yeah, do your best to keep them square. What I'm now going to do is obviously take the measurements for this subframe, get those cut, get it all fixed in place, and then hopefully get the casters on and we can get this flipped over. So the subframe is now in place. The way I achieved this, instead of assembling the frame and trying to slide it in as once, that would have been very tight with how close I made these inserts into the legs. So instead I put the two long pieces on either side, slid them out one end by maybe just over an inch, put the joining piece in, screwed from either side, knocked it through to an inch the other side, did exactly the same, and then leveled it back up with the legs so everything now sits nice and flush. And then just pinned a screw in either side of the leg to hold this frame in place. I've got to put one more support button in the middle, but then yeah, we're nearly ready to flip this over once the casters are on. So the brace is in position. We're now moving on to fitting the casters, which are just 4 screws per caster, so nice and easy. A couple of things to factor in if you are fitting casters. The weight's usually rated per wheel, and you often want to overcompensate for this. So for example, these wheels that I have allow for 100 kilograms per wheel. So in theory, the weight of the bench and anything else sitting on top of it can go up to 400 kilograms, obviously distributed across the 4 wheels. The other thing you may want to consider as well is the type of brakes that they have. You obviously want to have brakes on them because it is a workbench, so you want to lock it in place, but there are different types available. I will put links to these ones. Obviously I like them because they're orange, but they're also suitable for this workbench. And if you want the best of both worlds, where you can move your workbench around but still the stability of having those solid legs on the ground, take a look at casters like these. They effectively can engage and disengage, so ultimately you can lift your workbench up, move it around, then disengage them and drop it back down and continue working with those 4 solid feet touching the ground. Again, I'll put links in the description area to casters like these. Now just a quick tip when you are fitting them, because you are screwing into end grain, you can very easily over tighten them and obviously the screw will just continue to spin. So if you are using something like a driver, take it so far and then just finish the last couple of turns off by hand so you know how tight they are and you don't over tighten them. So all the casters are fitted. The next step is to flip the frame over. Remember, I haven't fitted it to the base at this point, so what I'm probably going to have to do is move it to the side, flip it over, and then we're going to get the work surface on top. I'm recruiting my dad in to help me with this one, so I'll go and grab him now and we'll get this flipped over. So after flipping it over and putting this on, I did realise that 1 or 2 of the legs were a little bit proud. So I've just had to flatten those off. You can do that with a saw, with a plane, anything you've got. You can even sand them down. Ultimately, it just needs to be flush with the frame. Now before fully fitting the top work surface, I'm going to fit the underneath shelf. This is 11mm OSB. I'm just going to cut the rectangle out, notch the corners out, and obviously fit it in place, doing all the cuts with a jigsaw. It can be done by hand if necessary. The reason I'm doing this first is if I need to move the top work surface out the way just to give me a bit more wiggle room or access, it will be easier than trying to do it with that fixed down. So I'm going to get on, get this cut and get this fixed in now. So the base shelf is now in place. I've just fitted a very small countersink bit on this. I'm just going to pilot a few holes and then put some very small screws in to hold everything in place. So the shelf is now screwed down. I've aligned the top as best I can. It all looks pretty square. The one corner over here is about 1mm proud. The frame is proud in relation to the surface. However, for the size of this build, I'm pretty happy with that tolerance. I can always sand that back or plane it if I want it to be perfectly flush. Now, same process again. I've got to go and drill a load of pilot holes, get this all screwed down. I did debate gluing it down because I think, well, obviously it helps make it more secure, and I think it minimises some of the drum type sound and just makes it a little bit better acoustically. However, I may be modifying this table in the future, so I'm not going to glue it down, but it's something for you to consider obviously with doing your own build. So yeah, I'm going to get this screwed down and well, that should be it finished. Now when you are screwing the board down, start in one position and work outwards, as you may have seen in that short clip then. And also make sure your screws are pulling the wood down to the frame itself. You don't want no gap in between there, because ultimately the tighter they are squeezed together, the stronger it is going to be. Now there are still 1 or 2 minor things I've got to do to this, such as giving it a quick sand down and also pouring a top coat on this work surface just to seal it. But ultimately, well, that is our workbench done. We have turned the drawing into reality, and as I said at the start, I'll put a full cutting list down in the description area should you want to replicate this. And also the joys of this design, well, it can be scaled up or down, obviously depending on what your needs are, just by adjusting some measurements. I do hope you have found the video useful. If you have, of course, please give it a thumbs up and make sure you subscribe if not done so already. Thank you very much for watching, and as always, final thanks goes to my patrons. If you want to get involved for one-to-one help, giveaways and early access to content, then definitely check out the Patreon links in the description area below. I will see you all on the next episode.